Hello, I'm Miss Pritchard,
And I'm Mr. Voigt.
and we're here today to show you how to perform a t-test on a skillscast to show you how to compare two pieces of data. For example, what I've got here is I'm comparing the height of all of the boys compared to the height of all of the girls. And my hypothesis is all boys are taller than girls. And what the t-test will do, the t-test will either confirm that this is true, or my null hypothesis, where there is no significant difference between the heights of boys and girls. So the best place that you can use a t-test for in most circumstances is for ecology, where you're comparing two different areas and you're collecting lots of data about one particular item. In this case, it's boys for me, compared to another item, which is girls.
Another area you might use this is if you were doing a microbiological sample of, say, antibacterial and seeing whether colonies are, less in number on one plate as compared to another. But basically, you're comparing two data sets of numbers. You want to look at the confidence testing, and you want to be 95% confident in the fact that your data, there is a significant difference between the data. So we're looking for a p-value of 0.05 once our t-test is performed.
So to perform the t-test, and really nice and simple, you've got your set of data that I've collected here from all my boys, all of the heights and all the heights for the girls. So I open my formula builder by clicking on the fx function here, and I want to double click on the t-test. Now for array 1, that is my first set of heights from the boys, and for array 2 is what I'm comparing the boys' heights to, which is the girls. Now for tails.
The tails are looking at what sort of distribution you're looking at. For biology, we usually use a normal distribution, which is the two tails test. So we are going to be putting the number 2 in this position to represent that we're looking at two tails.
And the type?
The type, if you look down the bottom, you can actually find out what the tails and type mean. Now we're also going to be using the number 2 because we're looking at paired sample. So it's a paired sample, so the two sample unequal variant, we sampled with an equal variance, so we're using the number 2 in this one.
There we go, and then you just click done. And my answer is 0.109 yada yada. I can change the decimals just to, oops, that's increasing. There you go, just to round it up a little bit. Now, in science, we always talk about, the 5% significant level or 0.05. And in this case, this number is now too high. It's much higher than my significant level. So I have to accept the null hypothesis that not every single boy is taller than every single girl. And as you can see, some boys are a bit shorter than some of the girls here, and that is the reason for the outcome.
So with the confidence, if you're looking at the number there, 0.109, that's suggesting about 11% of non-confidence. So you are not 95% confident in the data that you've got, that there is a difference. So you have to reject the hypothesis and accept the null hypothesis. That gives you a lot more to talk about in your actual analysis and discussion and evaluation sections, which is really good for a lab report.
Okay, so we hope that was helpful to you, and we will see you again sometime. Goodbye.
Bye-bye.